Good morning, ladies and gentlemen, boys and girls of all ages. Today is May the 6th, if I'm correct. Hope you guys are having yourself a good Wednesday morning. So we're going to continue talking about probability, but specifically we're going to talk about independence and dependent probability. Specifically more on the independent side. Now, for those of you who don't know, we need to understand what makes things independent or dependent when it comes to probability, or what does it mean to have an independent or a dependent probability. So, we have to consider things back to many years ago when we were talking about variables. When thinking about variables, we often had x's and y's. And we knew one of these was an independent variable, one of these was a dependent variable, with typically the x variable being independent. Well, what did it mean to have an independent variable, and what did it mean to have a dependent variable? A majority of kids say, oh, an independent variable can stand by itself and a dependent variable can't. I get that definition, but I don't like that definition. Think about it like relationships. An independent variable, true, an independent person doesn't rely on anybody else, but I often see that an independent person affects the dependent person. This person relies, this variable relies on the independent person to determine what it is. And the same is true for probabilities. If you have an independent probability, one probability does not affect the other probability, or one probability does not rely on another probability. But if it's a dependent probability, the probability of x will affect what the probability of y is going to be. Or you can say it the other way, the probability of y depends on the probability of x. But I like it more as the probability of x would affect the probability of y if it's dependent. Independent means that they simply won't affect each other. Now, for the next following situations, I want us to understand whether they're independent or whether they're dependent, and we need to give a reason why. Tossing a coin and drawing a card from a deck of cards, obviously. Now, is this independent or is this dependent? Well, this is independent. Because if I have a coin, it either can be heads or it can be tails. If I'm drawing a card from a deck, well, there can be 52 cards in a normal deck of cards. Well, the coin isn't going to affect whatever the card is going to be, and vice versa. Getting a raise in salary and purchasing a new car. Well, that could very well be dependent. Normally when people get an increase in money, there's often a trend of spending more money. So purchasing the car, the probability of purchasing a car could be dependent on whether or not there's a good probability of getting a new salary. So that could very well be dependent. The car depends on what the salary is going to be. Having a large shoe size, and having a high IQ. Now, this, in my opinion, would be independent. If you have a large shoe size, well, I mean, you could have a large IQ, you could not have a large IQ. I really don't see any correlation or any link between the two. And driving on ice and having a car accident, I think that would be very dependent. That'd be very dependent. If it's slippery outside, you probably don't want to go driving around that quickly. If you ever drive across country and you drive across a bridge in a country area, it says, it often says something like, oh, ice appears on the bridge before it appears on the road, and that's very true. And you don't want to have a wreck while driving. So yes, driving on ice could very well affect whether or not you have a car accident. So that is a dependent probability, or a dependent situation. Now, take a moment, pause the video, work these out on your own, and think of a reason why it'd be one or it would be the other. Are the following situations independent or dependent? Give a reason why. A father being left-handed and a daughter being left-handed, smoking excessively and having lung cancer, smoking cigarettes and eating ice cream excessively. Once again, pause the video, work them out on your own, think of a reason why. Now, for this last one, independent. I might be wrong, I'm not a doctor, but I don't think smoking and ice cream consumption is connected. But even though I'm not a doctor, I would definitely say smoking excessively and lung cancer could definitely have a relationship together. Now this top one is very unique, a father being left-handed and a daughter being left-handed. That could very well be independent, but depending on what you believe about genetics, it could also be dependent. So I'm going to say that this one depends. But I would lean more towards independence. For all the left-handed people I know, I don't think their parents are left-handed. Alright, so back to being independent or dependent. But if you have two situations that are independent, in order to find out what they are, in order to find out their intersection, the probability of their intersection that we talked about yesterday, if multiple things happen at once, you just multiply them if they're independent. If they're not independent, you multiply the probability of one times the probability of the other, given the fact that A has already occurred. Now that we're going to focus a little bit more on that later, but we're going to focus more on just this on this top one. I almost said numerator. Alright, determine this is independent or dependent. Calculate this probability. 68% of US houses play video games. If you choose 4 households at random, what's the probability that none of them play video games? Well, one thing we're definitely going to need to know how to do on this one is that if 68% of households play video games, what's the probability that they do not play video games? Yes, that's my kitty cat in the background meowing a lot. She seems very talkative today. So, if the probability of video games is equal to 0.68, what's the probability of not playing video games? Well, this is what we call a complement, which we will talk about more later. That's going to be 1 minus the probability of playing video games. So that's going to be 1 minus 0.68. If my math serves me correct, that is going to be 0.32, or 32%. So if you pick a single house at random, well, the probability that they play video games is 68%, the probability that they don't play video games is 32%. Well, if you're choosing 4 households at random, and you want the probability that none of them play video games, that means every single one of them has to have a probability of this. Well, according to this rule up here, all we have to do is multiply them together, because this is independent. Because the fact that one house doesn't play video games doesn't change the probability that the house might play video games, so this is definitely independent. And where did my mouse go? There's my mouse. So, probability that 4 houses don't play video games is not going to be 4 times this probability, it's going to be this probability to the 4th power. So that's going to be 0.32 times 0.32 times 0.32 times 0.32, a little tedious, or that's simply 0.32 to the fourth power, which is 0.0105. So this is about 1.05%. So, because video games are so prevalent in our society, the odds are if you pick 4 houses at random, the odds that none of them play video games is about 1% or 1.05%. That's because they are independent. One house does not affect the other. Alright, let me circle that answer. So, determine if the probability is independent or dependent. Calculate the probability. A flashlight has 6 batteries, 2 of which are defective. If 2 of the selected batteries are if 2 are selected at random with replacement, find the probability that both are defective. Word choice on this is very, very, very important. We have to understand what it means to have with replacement. If I have 6 batteries, 1, 2, 3, 4, 5, 6, and I select this guy, but I don't replace him, well, there would be only these batteries left to select, and that's definitely changes what your probabilities are. That'd be dependent. But since I replaced the battery, all 6 original batteries remain, therefore my probabilities are independent. So we definitely know that this is independent. If we want to calculate this probability, with 2 of them being defective, well, if you select one battery out, we have to go back to what we did yesterday. Oh no, what we did Monday. We want to figure out how many of them have the value that we want. Probability of defective battery. Well, that's going to be how many that we want versus over how many that there are in total. Well, if I'm selecting one battery, well, we know that there's 2 defective ones, and there's 6 total. So that's 1/3. Well, that's for 1. Well, what do we do in the last problem though if there's more than 1? Well, that's going to be it squared, because there's 2 of them. So that's going to be 2/6 times 2/6. Well, you can multiply them straight across. That's 4/36. Well, 4/36 is just the same thing as 1/9. And there's your probability. If a flashlight has 6 batteries and 2 of them are defective and you're selecting 2 with replacement, the probability that both are defective is going to be 1/9. Now that's going to be very different from if you do it one at a time. If you did them one at a time and did not replace them, well, the first one doesn't change. That would still be 1/3. But the second one, your number of batteries are different. There's 1 defective left and 5 batteries left over. So that's going to be 1/15 without replacement. This is without replacement. This would be dependent, because this is the value of A, probability of A, and this would be the probability B, given the fact that A has already occurred, because your probability has changed. But I'm going to focus more on independent for today. Back this page up. This is very important. Definitely write that down. Oh, there's my other kitty being super meowy. Alright, ladies and gentlemen, I hope you guys have yourself a great Wednesday. Stay safe. As I said, have a nice day.